a power curve. First of all, we'll look at the assignment. And the assignment involves running an SPSS program in the SPSS as an SPSS syntax file. And what we're going to do is we're going to look at power. Power is the probability of rejecting the null hypothesis when in fact the null hypothesis is false. That is in fact a correct decision. It's when real world has an effect and we discover that effect. And this is where we generally want to be when we do a study. Now we know that power is affected by 4 different things. The first is sample size. The second is size of the error. That is and if we're doing an ANOVA simulation, the error is the variability within groups. It's also affected by the size of the effect and the size of alpha. So what we're going to do is we're going to hold the error variance constant, and we're going to hold the size of the effect constant, and we're going to look at the relationship between sample size and alpha, and that's going to be our power curve. Now, in order to generate this power curve, to do our simulation, what we're going to do is we're going to open up an SPSS file. We're going to create a new syntax file. We're going to take the program that's given you, copy it, and paste it into the syntax file. Now we note that we've got spaces between our commands, which we don't want. So what we're going to do is we're going to delete those. After deleting the excess lines, the next thing we're going to do is we're going to set the size of the effect. Now, the default is 3.5, but we want to change it to whatever our problem is. So in order to do that, we go back to our gradebook. We click on Form, and we see that the size of the effects we're going to generate is 3.73. So we go back to our SPSS, our syntax, and we change the 3.5 to 3.73. And we're going to save this. On my desktop and call it temp. Now, what we want to do is we want to run this program, this SPSS syntax file. In order to do that, we just highlight everything and we hit the green arrow. And it does 2 things for us with this SPSS program. First, it's going to generate a data file. It's going to just generate random numbers. And if we look at this data file, we see that it generates lots of numbers. It generates 102 variables. The first 2 variables are going to be designation of group membership. It's either group 1, 2, 3, 4, or 5. And the second would be subjects within that group, 1 through 10 in this case, because we're generating 10 subjects. So this is our data file, and every time we run this program, it's going to generate a new data file, a different data file. And the second thing we get is our SPSS output file. And what this does is it's run 100 analyses of variance, one for each of the variables. These are the means of each of the variables. And it's done 100 analyses of variance, which is a lot. Now, what we want to do is we want to count the number that are significant. We want to count the number that are significant at the 0.001 level. We want to count the number that are significant at the 0.01 level. And we want to count the number that are significant at the 0.05 level. Now, we could do that. We could do the 0.05 level, for example, by going, well, that's not. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. That one's not. 10, 10, and so forth. It would take us forever. Then we'd have to go back and do it for the 0.01 level, and we'd have to do it for the 0.001 level. And because we have to do this at least 20 times, because we're going to have 20 different sample sizes or n's, it's rather tedious. And in order to avoid that kind of tedium, what we've done is we can copy this ANOVA table, and we're going to go back to our output, back to our view, back to our view, and we note that we have a document, an Excel document that we can load. And we're going to open this file. This is the document that we load. The first thing we're going to do is we're going to clean it up a little bit. We're going to redo all these numbers. First thing we're going to do is we're going to delete the numbers that are there because we don't need these. We'll just hit the delete key. We'll delete the numbers that are there because we're going to generate a new power curve. And then we're going to go to the worksheet, and we copied the ANOVA table. And we're going to paste the ANOVA table that we generated with SPSS in here. And what we're going to do is we're going to count these significance. We're going to sort these and count them and make life a lot easier for us. In order to do that, we'll delete the first 2 lines. We will highlight everything, and we need to unmerge everything. Now we can sort. And we'll do a custom sort. We don't have any headers. We'll sort by column H from lowest to highest. And now counting becomes pretty easy. If we want to count the number that are significant below 0.01, we simply look at how many are 0.01 or less, and it looks like 34. So now we can go to the power curve, and this one, with this particular one, the default was 10. So we can go up here at 10, at 0.01 was 0.34, because 34% of our analyses were significant at the 0.001 level. Going back to the worksheet, we look for 0.01, and we find 55 were 0.01 or less. So going back to our power curve, we can go to 0.55. Going back to our worksheet, we look at 0.05, and we find 78. Okay. Now, we have to repeat this from 2 to 19 in order to change the sample size. We go back to our syntax file, and loop 2 changes the size of the sample, and let's make that 9. So all we did was change this one number. We're going to leave the effect constant, the effect size constant. We're just going to change that 9. rerun the analysis. We generate a whole new set of data. We generate another 100 ANOVA tables. We copy that. Go back to our Excel, our worksheet. Paste. Delete. Unmerge. Sort. And it stays the same. And now count up just like before, but in this case, because we have a smaller sample size, we've got less power. In this case, we only have 26 that are 0.01 or less. So at 9, we'll put 0.26. Going back to our worksheet, at 0.01, we have 51. And at 0.05, we have 77. Now, if we ran this again, we'd get different numbers. We'll go back and do back to the analysis of variance, back to SPSS, and change now. Let's do, rather than 9, let's do 11. Again, we've generated 100 different ANOVA tables. This time, each one has 11 subjects in it. Back to Excel. Back to our worksheet. Unmerge it, sort, and with 11 we have 42 at 0.001. Again, we gain power. With more subjects, we gain more power. 0.001 would be 68. So that will be 0.68. And at 0.05, we have 86 that are significant. We'll do one more just to illustrate what it is. We'll go back to our SPSS and we'll now look at 8. Change this 11 to an 8, loop 2 to 8. Rerun. Another 100 analyses of variance. Back to the top, paste it, delete the top 2 rows, unmerge, sort, And at 0.01 we have 20. Or 0.20. At 0.01 we have 39. And at 0.05 we have 73. Okay, I'm going to continue doing this, and when I stop doing it, I'll show you the result. Okay, I'm back. It's about 15 minutes later, and I've completed the power curve. Note that it's reasonably smooth, but there are some drops. I would probably smooth this out when I'm going to answer the items on the assignment.